the video today, we're going to be discussing section 7.2, which is trig integrals. We start by looking at a couple examples and then get into some strategies for how to solve more complicated ones and look at a few examples involving those. So first off, start with an example. That's going to be number 1, and it's going to be product of cosine. So we want to integrate cos cubed of x dx. Now, cos cubed, you just know is cosine times cosine times cosine, so a product of 3 cosines. And the first thought for this is going to be to do a u substitution. However, that's not going to work because we have nothing to really substitute here. So at first, so we have to manipulate this using a trig identity, and then we can do a u substitution. So we can rewrite this as integral of cos squared of x times cos of x dx. Those two things are equal. We're just breaking off one cosine. At this point, we can use an identity, and we're going to use the identity that sine squared x plus cos squared x equals 1. We can manipulate this such that cos squared of x equals 1 minus sine squared x. Now, if you notice anything, we have this and this that we can have interchangeably. Therefore, we're going to do that. So we have integral of 1 minus sine squared x times cos x dx. At this point, we can do a u substitution. So we're going to let u equal sine x. Du is going to be equal to cos x dx. And now we can just plug in. So we have integral of 1 minus u squared du, because du is equaling all of this, so this whole thing is being replaced by du, this is being replaced by u squared, and then the 1 is staying. So we're just left with 1 minus u squared du. Very simple problem from here, because all we have to do is integrate this, which is going to become u minus 1/3 u cubed plus c, and that we plug in our u value, so sine of x minus 1/3 times sine of x all cubed plus c, and then this can just be rewritten slightly simpler as sine x minus 1/3 sine cubed of x, because that exponent really belongs inside there, plus c. And that's our final answer. So again, this shouldn't be too difficult, just relying off of a trig identity. The second example we're going to look at before we get into some new ideas is going to be integral of sine to the 5th of x times cos squared of x dx. Again, you notice if we have an odd power, that's usually going to indicate that we need to break something up. Not always, but most of the time. So we're going to break up sine to the 5th of x. So we'll rewrite this as sine to the 4th of x. So we're just breaking one sine value off of there, times cos squared of x times sine of x dx. Again, they equal the exact same thing. Now we're going to use same identity as before, and that's going to be that sine squared of x equals 1 minus cos squared of x. So that same principle from before. And then we can rewrite that sine to the 4th as 1 minus cos squared of x squared. So we have integral sine squared of x squared, so we're just rewriting that as sine squared of x squared, times cos squared of x times sine x dx. And then we're just substituting in this whole part right here into there. So we have integral of 1 minus cos squared of x squared times cos squared of x times sine of x dx. Now we can do a u substitution, so we're going to let u equal cos of x. Du is going to equal negative sine x dx, and then in this case it's going to be better if we say negative du equals sine x dx, and just go that last step because we're dealing with a positive sine of x right there. This point, we'll rewrite this as negative integral 1, we know u is cosine, so 1 minus u squared, now that is quantity squared times u squared, and then this whole term here is rewritten as du, so times du. That negative we already brought out in front right there because it's really negative du, so we went ahead and factored out the negative value. Now we want to expand what we have in our parentheses, so we're expanding this term. So remember, this is just written as 1 minus u squared times 1 minus u squared. Those two things equal each other. So we have negative integral. What's that going to be? 1 minus 2u squared minus u, or plus u to the fourth rather, all in parentheses, times u squared du. So all we did in this step is expand what's in the parentheses there. Now we'll come down here, so we're just following the inequality chain, or the equality chain over here. And we'll rewrite this as negative integral, and now we just need to distribute that u squared inside the parentheses there. It's going to be negative integral of u squared minus 2u to the fourth plus u to the sixth du. And then this is very straightforward integration problem from Calc 1 right here, which is going to be negative times 1/3 u cubed minus 2u to the fifth over 2/5 u to the fifth plus 1/7 u to the seventh, and then plus c. And then we can add in our u value. Again, that was listed up here. U is cos of x, so we're just adding in our u value. So it's going to be negative, and then we'll distribute the negative in also, so negative gets distributed to all those terms. So we'll do that simultaneously. So we have negative 1/3 cosine cubed of x plus 2/5 cosine the fifth of x minus 1/7 cosine to the seventh of x plus c, since this is an indefinite integral, and that's our final answer for this problem. Again, just using that identity and then the u sub. So that shouldn't be too difficult, definitely easier than integration by parts. Next, we're going to look at an example that requires a double angle identity. So this one is going to be integral of sine of 2x times cos of x dx. Well, we'll rewrite this as integral of 2 sine of x cos x. So we're just rewriting that first term, rewriting this here, and then times cos of x, and then that's all times dx. Well, we can factor out that 2, so we have 2 times integral of cos squared of x times sine of x dx, and then we're just doing a u substitution where we'll let u equal cos of x, du equals negative sine x dx, and then negative du equals sine x dx. So this whole thing's going to equal negative 2. We'll factor that negative out right now. And then integral, well, u equals cos of x, so that's going to be u squared. This term here is turning to u squared. Du equals negative sine of x. We already factored the negative out, so it's just u squared du. Integrating this gives us negative 2 times 1/3 u cubed plus c. Now we'll just plug in on what our u value is, so, and combine the negative 2 and the 1/3, so that's going to be negative 2/3 times, what is u? U is cos of x. That's quantity cubed plus 3, plus c, I mean. And then we'll just say finally, because the exponent really belongs inside there, negative 2/3 cos cubed of x plus c. And that's our final answer for this problem. Again, relying on that double angle identity. Next problem we're going to look at is going to be integral of tangent to the 6th of x times secant to the 4th of x dx. Well, we're going to rewrite this as tangent to the 6th of x times secant squared of x times secant squared of x dx. Again, same thing, we're just splitting it up, similar to what we've always done. That's going to equal integral tangent to the 6th of x times tangent squared of x plus 1 times secant squared of x dx. So we're using an identity that secant squared of x equals tangent squared of x plus 1. So we're rewriting one of these secant squared of x as that. So we're just using that identity and doing a rewrite. Now we'll do a u substitution. We'll let u equal tangent x du equals, remember, derivative of tangent is secant squared of x dx. That's going to equal our du value. And now we can just do a nice u substitution so that we have integral of u to the 6th, that's u right there. That's going to become du. So we just have u to the 6th times, well, that's u again, so u squared plus 1 du. At this point, we're just going to distribute that u to the 6th inside the parentheses there. And then it'll be a simple calc 1 integral. So integral u to the 8th plus u to the 6th du equals 1/9 u to the 9th plus 1/7 u to the 7th plus c, since this is indefinite, and then we're just plugging in our u value back in, so tangent of x. So I'm going to have 1/9 tangent to the 9th of x. I'm not going to rewrite this separately, so just tangent to the 9th of x plus 1/7 tangent to the 7th of x plus c, and then put a parentheses there, and that'll be our final answer for this problem. And the final example we're going to look at for today is going to be integral of tangent cubed of x dx. Well, again, we're going to rewrite this and break this down, so we're going to break it into tangent squared of x times tangent x dx. And just a reminder, if you see those odd powers, that usually indicates you need to break something down. Not always, but sometimes that's a good indicator that you can break it into the even powers, because that's what most of the identities deal with that become useful for us. So remember, tangent squared equals secant squared x minus 1. So we're going to rewrite that as such. So we have integral of secant squared x minus 1, and that's going to be all times tangent x dx. So now we're just going to distribute this tangent x inside the parentheses there, both of those terms. That's going to give us integral of secant squared of x times tangent x, and we're going to break this into two separate integrals at this point, minus integral of tangent x. So this is going to be our first integral right here. Secant squared x times tangent x, that's going right there, and then tangent x times -1, that's going right there. So we're splitting it into two integrals, makes it a little bit easier for what we're doing. Okay, so we'll rewrite this again is integral of secant x times secant x. So again, that's an even power, but we still want to break it up. It's going to make things a little easier. Times tangent x minus integral of tangent x dx. Now we're going to do a u substitution. So we're going to let u equal secant of x, and this is specifically for the first integral that we're doing the u substitution for. The other one, it's not necessary, so we're just focusing on u substitution, first integral. U equals secant of x dx. Du is going to be secant of x tangent of x dx. So that's the derivative of secant x. So we can rewrite our integral again as integral of u du. Du equals secant x tangent x. So we have this whole thing there equaling that, and we're representing that by du. So that's where we're getting du from. And then minus just what we had in that first integral, tangent x dx. So now this is pretty straightforward. We have 1/2 u squared minus derivative of tangent x is going to be ln absolute value secant of x plus c. Now we just want to plug in our u value, which is secant of x, so that we have 1/2 secant squared of x minus ln absolute value secant of x plus c. And then that's our final answer for this problem, and that's going to conclude our topic for today. I know this mainly focused on examples and not necessarily strategies. Most of the strategies for this result directly from identities. All the integration stuff is really straightforward, but you have to know the different identities, which you should have learned in previous classes. And that's really what's going to become useful for these. If you don't know the identities, it's really difficult to do these problems. So learn the identities. The integration itself is pretty straightforward, which is mainly what we're focusing on in the video today. Just applying those identities, doing the integration, and then solving the problem. So with that, our video for today is concluded.